Hello everyone, this is an explanation video detailing the concept of best fit and first fit in computer operating system memory management under the topic Fixed and Dynamic Memory Management. Early computer allocates memories contiguously, so as computer architects, we are tasked to make this allocation as efficient as possible without wasting any memory. To make it easy to understand, we assimilate this concept to the real-life application. We applied the concept to a situation at a restaurant. Imagine you are the host of a restaurant and you are managing the front of the house. Your restaurant has one entrance. Your restaurant has a long line of tables for your guests, all with different sizes for a different number of guests who came in groups. The table size are 6, 4, 2, and 10, and they are lined all the way to the back of restaurant. This shall be our representation on what is going on in memory allocation. The customers are the jobs that needs to be executed, and the table are the partitions of memory that are arranged contiguously. As a host, how are you going to escort your guests into the restaurant? Now, this is how a host will seat their customers following the best fit algorithm. This host does not care for speed, but is more focused on getting as many people into the restaurant as possible. The group 1 of 2 customers enter the restaurant. The host wants the table to be the smallest it can be while still fitting the customer. The host confirms that the first table can seat this group, but to make sure that this is the smallest table, the host will check the next table. The host checks whether the table is smaller than the previous table and can fit them. The host will check all the tables in the restaurant. Lastly, the host will seat the customer to the smallest table that can fit them. Finally, after checking all the seats, the host places them at the smallest available table. The host does the same for all customers. You can see, despite it being able to fit more customers into the restaurant, the customers are left waiting in line for a very long time. This is the summary of the best fit algorithm that was explained earlier. This is how the first fit algorithm will handle this problem. The host decides that the fastest way to seat the customers is to place them in the first empty table the host sees. The group 1 of 2 customers enter the restaurant, so the host checks the first table. The table is empty and can fit the group 1 customer, so the host directs the group 1 customer to the table. Now that is done, the host will proceed to seat the next group of customers. The host will always check if the table is empty. If not, the host will move and check the next table. The second table can fit the customers, so the host directs the group to the second table. The next group of 4 customers enter the restaurant. The host will always check for an empty table from the first table. If not, he will move to the next table. As he arrives at table 3, the table is empty, but it cannot fit the customers, so the host moves to table 4. The table can fit the customers, so the host directs the customers to the table. A group of 6 enter the restaurant. As you can see, there are no empty tables that can fit this new group of 6, despite there are enough seats in the first table to seat them. Because of this, they are forced to wait until a group of customers leave and the table has enough seats for them. This is the summary of the first fit algorithm that was explained earlier. As we can see, job 4 has to wait until large enough block is available. These two hosts have different approaches to seating their customers. The best fit host wants to seat as many as possible despite being slower, and the first fit host wants to seat them as fast as possible despite wasting the table seat. This is how some operating systems manage their memory. This animation is produced by Ahmad Zul Hakim, Lee Tong Ming, Muhammad Azim, and Saharut. Thank you for watching.